Leaves their higher level 2018 paper 2 question 9 is this crank and slider mechanism where we're given 5 diagrams before we get to the question. So we're told OD is equal to 10, which is the radius. We're told CD is equal to 30, which is this side here, and you can see that this moves around in a circular motion and can end up back here. So we're given 3 different diagrams then, and then we're given a 4th, 5th diagram, and we're told to find the angle COD. Well, this is just a triangle where we have some pieces of information. So put the pieces of information onto the triangle. We have 15 degrees. We have the side opposite, which is 10. We have 30, and COD is this angle in here. So we're looking for, let's call it X. So you can see we have sides and the angles opposite. So this is the sine rule. So 30 over the sine of X is equal to 10 over the sine of 15. So 30 sine 15 divided by 10 is equal to the sine of X. This gives the sine of X. You could just get the angle at this point if you want to get the inverse sine of this fraction, but maybe just write out the decimal first. It gives me 0.77. Take a few more, 645. So the inverse sine of that is going to give me X to be 51 degrees. In part B, you're told as D moves in a circle around O, the angle alpha in the diagram below, which is this diagram here that was given, this angle alpha obviously increases. The distance CX can be considered as a function of alpha and written as f of alpha. Write down the period and range. Well, we know in a full circle we've got 360 degrees. So the period would have to be 2 pi. The range, so when D, if I move D back to here, CX will be 30. But if I bring D all the way around to the far side of the circle, that's the minimum it's going to be when it's there. The radius is 10, so that distance will be 20. So C would shift into here and will be 10 long. So the range is between 10 and 30. Between 10 and 30. Complete the table below for f of alpha, correct the 2 decimal places. So this is the length of CX depending on where the angle is. So the first, you're given 0 degrees and you're told that it's from the very first diagram of 400 diagrams. This one here, diagram 1, it was numbered diagram 1, and you were told that this is 0 degrees. So you can, D is going to move up to here, it's going to be 90. It's going to move around to here, and then we have 180. It's going to move down to the bottom, and we're going to have 270. Then it's going all the way back around to 360. So 360 and 0 are going to be the same. So you can fill that in, that's going to be 30. So let's have a look at the first one, 90. So if it creates a 90 degree angle, we have a 10 here, we have a 30 here, and we have a right angle triangle. So CX is going to be from here to here, and then we're going to have the radius of 10. So I just use Pythagoras here, the square root of 30 squared minus 10 squared. It's going to give me 28.284, 28.284, we're told 2 decimals, so 28.28 will be the full length from here all the way to here. So take away 10, and we're going to get CX to be 18.28. Now, as I said, if we come down the bottom, we're going to have exactly the same triangle, just it's going to be flipped upside down. So 270 is also going to be 18.28. And 180, well, we have the 180, that's the, we got that already up here for the range, that's going to be 10. Because we have 2 radiuses. So we'll have to have this distance here being what's left, which is also 10. Part 3, you're asked to use your values from the table to draw a rough sketch of f in the domain 0 less than or equal to alpha less than or equal to 360. So just drawing a little diagram here. You were given graph paper, or you were given a grid in the exam and told to draw on it. So what have we got? We have our max and min values. So you should identify the quadratic nature of this graph because it's going up and down. So we have a 30 at 0. We have a 10 at 180 and a 30 at 360. So a 10 at 180 and a 30 at 360. and we have 18.28. Is that what we got in between? 18.28. So approximately here. And the same here. So the curve, it's going to go down, back up, then it will come down again if it kept going. So it's just a rough sketch. In part 4, we're asked, referring to diagrams 1, 2, 3 at the start of the question, for which of the 3 positions of the mechanism will a 1 degree change in alpha cause the greatest change in the position of C? Well, we're going to come back to this diagram here now. And this is to do with slopes. Because if we look at these diagrams here, this is diagram 1, 2, and 3. This was actually a lot more over here. So it was closer to this 180 degree angle here in the diagram. So what they're kind of referring to here is the steepness of the curve. So we can see at this point here, we have a slope of 0, a slope of 0, slope of 0. So where's the maximum point along here? Where's the maximum steepness of this curve? And it's at this point here, halfway along between 0 and 180. So when the mechanism is closer to 90 degrees, it will cause more of a push or pull on C than at any other point along the curve. So it could also be at 270 as well, going up the other side, but the diagrams were given like this. So this is the diagram where it was closest to the 90 degree angle, which is what they're looking for here. So the answer to this part is diagram 2. Kind of a tricky question, that. Diagram 2 was a 5-mark question. In the last part of this question, you're given a new crank mechanism with the values 36 for AB, 31 for AX. So this is OR, wasn't given. This OR was between B and O, and the 10 degree angle. So if we just take that triangle out again, we're looking for OR here. So I just do a version of the triangle. We have OR, so 31 plus OR is this side. We have a 36 and we have a 10. So I just have one unknown OR, but I have 2 sides here in the angle in between, which is the cosine rule. So OR squared is equal to 36 squared. It's always the side opposite the angle is the one on its own on the left, plus 31 plus OR to be squared, minus 2. If you don't know the formula, A squared is equal to B squared plus C squared minus 2BC by the cos of the angle in between those 2 sides, cos of A, by 36 by 31 plus OR by the cos of 10. Okay, so a little bit of simplification involved here. OR squared is equal to 36 squared is 1296. 31 plus OR to be squared. 31 squared is 961. Plus 31 OR twice is 62 OR plus OR squared. And then we have minus 2 by 36, so minus 72 by 31. So that would be minus 72 by 31 by the cos of 10, which is going to give minus 2198.09. And then we have minus 2 by 36 by OR by the cos of 10, so that's minus 72 cos 10 by OR, which is going to give minus 70.91 OR. So you can see my OR squareds cancel. I have on this side 8.9 minus 8.91 OR, so I bring that to the left. 8.91 OR is equal to, tidying up the numbers, I'm going to get just close to 59, 58.9. I'll round it off to 59 because we're asked to the nearest whole number. So OR is equal to 59 divided by 8.91. Which is 6.62. 6.621, and we're asked for the nearest whole number here in this question. So OR is equal to 7 to the nearest centimeter.